Let's practice our factoring first. This one's easy. Two numbers that multiply to 3 and add to 4. 3's spread. I mean, really only have 3 and 1 to pick from, right? Then, of course, it wants the solutions. You need the two answers for x. So you would subtract 3, subtract 1. That. Okay. Now, 2 is just a touch more dicey because I want it to look like 1, meaning I want it in that order and I want it set to 0. So I'm like, okay, all right, let's make this a 0. I'm just going to subtract it. Notice I just kind of threw it over there in the middle on the other side. But when I write out the terms on the other side, I'm going to be super conscientious. I'm going to put the squared term first, then the x, and then my minus 9. Now I could factor on it just like it is and I could make it work, but here's a pro tip for you. Anytime you have this negative in the front, it's so easy to make a sign error at some point. So make it easy. Switch all the signs. You can do whatever you want as long as you do it to everything. Now I'm like a piece of cake. Multiply to 9, add to -6, -3, -3. So technically we have two answers. They just both happen to be 3. The same thing. Do you have to write it twice? No. Can you write it twice? But it's the same thing. So, like I said, just a little factoring review because we purposefully put some factoring, some algebra skills in these circle problems today, thinking about, you guys taking Algebra 2 next year and, of course, standardized testing. All right, so math humor for you. Ready? Why was the chord upset with the tangent after their race? Ready? It's super cheesy. You're going to love it. Okay, that's all I got for math humor for you. So we're going to do segment lengths today. So remember, that picture down there on the other side of the smartboard, that one is angles. We are on segments. So we're going to talk about chords again, secants, and tangent. We're going to throw a tangent in there. So let's get into the chord one first. So a chord, so wordy, but I promise you the math is easy. So fill out the blanks here. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the other chord. Whew, wordy. Okay, that is so wordy for something so easy. 1, remember, chords, a segment with endpoints on the edge of the circle. That's what a chord is. Okay, got it. So all you have to do is you're going to multiply the one piece of it times the other piece, and then you do the same thing for the other chord. So you're multiplying the two pieces of the chord together. That is over here, this first picture on the top left that we're going to work on. So simple enough to set it up. Does not matter which chord you start with. I don't know, I'm going to pick one. I'm going to do this one because I feel like it. So one of the pieces is x times the other piece of it, x plus 4. Now I'm going to put x plus 4 in parentheses just because I'm like, oh gosh, I'm going to have to distribute x to both of those, which we'll do in a minute. My other chord, again, doesn't matter which piece you start with. I'm going to start with x plus 1, the other piece x plus 2. We're going to times those together. So there's the geometry setup. Piece times the piece. Well, that's pretty easy. Now again, on purpose, this is going to have a lot of algebra in it to help review our algebra skills. Because we're going to have to distribute. So I'm going to have x squared 4x. I'm going to have to FOIL or distribute the right-hand side. X squared 2x 1x. I'm just going to put x. I'm not going to put the 1. 1 times 2. So at first glance, I'm like, oh man, I'm going to have to go through and factor on this like the warm-up problems. But we're lucky. X squared on either side, they're going to cancel each other out. So I'm just going to cross them off now. So I'm going to combine 2x and 1x. And that's a pretty darn easy equation to solve. Just subtract 3x off, and we're going to have x equals 2. Now, okay, as always, thinking about standardized testing, a lot of times you figure out what x is, but notice they want ML and JK. 2 is not my answer. I have to substitute those in. So let's do ML first. So if I put 2 in for this, 2 plus 1, this piece would be 3, 2 plus 2, 4. So M all the way to L, 4, 3, combine it, 7. Then I'm going to do the same thing for JK, or KJ, whatever you want to call it. Put a 2 in, of course, for both X's, 2 plus 4, 6. So the whole segment, 8. So just make sure, sometimes you'll see they just want X, sometimes they want you to plug it in and give the length. So the geometry today, I promise you, is easy. You just multiply the pieces, but there's going to be a lot of algebra today. I don't know if that's a good or a bad thing. Okay, more chords. Doesn't matter which one you start with. I'm going to start with this one. Doesn't matter which piece you start with. I'm going to start with the 4x. I'm going to do 4x times x. And then I'm going to do the other chord, which again, doesn't matter which piece you start with. I'm going to start with the 3x and the x plus 1. So there's the geometry. That's super easy. Now we get a lot of algebra, of course. 4x and x. 3x I'm going to distribute. And I'm looking at this and I'm like, oh man, the x squareds do not cancel. So I'm already like, ooh, I'm going to have to set it to 0 and probably factor on it, which is fine. Good algebra. I'm going to subtract the 4x squared over. Feel like we're in algebra 1 again. So 3 minus 4. Now, I can, of course, factor it with that negative on the x squared. We talked about this at the beginning. Personally, I think it's easy to make a sign error, so I just switch everybody's sign, because 0 is still 0. Okay, little different factoring than the beginning problems in the warm-up. Warm-up were all trinomials. You did what multiplied and added. Okay, no such luck here. You only have 2 terms. First type of factoring you ever learn in Algebra 1 is a greatest common factor. What do the 2 terms have in common? X. Let's factor an x out. What are your 2 potential answers for x? Everybody gets 3. What's the other one? 0. We have to set our GCF to 0. So we have potentially. Now, which one of those, 0 or 3, do you think I have an issue with? The 0. Because if you put 0 in here, how are you going to have a segment length of 0? So I'm just going to keep the 3. Now, as always, gosh, this is so much work. Read our directions. They don't just want x. Notice I didn't circle x. They want to know what RT and they want SU. So we have to plug in x and get the total length. So if I put a 3 in here, I'm going to have 3 plus 1, 3 times 4. So I'm just going to add that together for a total of 16. And then same thing, I'm going to put 3 in here, so 12. And 3, 12, okay, 15, got it. So they want the overall length of the segments. So just bear in mind, this very first green and red line was the geometry part of this problem. The rest of it is a lot of algebra review. You're welcome. Okay, this is not on your notes, just look at it. This is just reviewing the vocabulary, okay? Because you have to look closely at what types of secants, chords, tangents you have. Remember, chords touch the edge of the circle. Now we're going to start mixing in secants and tangents. Secants go all the way through the circle, just a little reminder, and they touch it twice. Tangent only touches the circle 1 time. So now, because we're going to have some mixed up here together, you have to look closely and know, do you have secants, secant and a tangent? What do you have? So when we have secants, anytime you have a secant, even if it's mixed up with a tangent, who cares? Anytime you have a secant, it's always the outside piece times the whole length of the secant. So this is what you have to fill in on the blank at the very bottom there. Now, if you don't like the word external, if you're like, I hate that, what is that? That's the outside piece, if that makes more sense to you. So anytime you have a secant, it's going to be, let's see, of course we don't have color copy machines, the outside piece is the red, and then you're going to have to come up with the entire length of the whole thing. Okay? Anytime you have a secant, whether it's 2 secants or mixed up with a tangent, secant calculation always the same. So here we go. So of course we have to know our segments. We have 2 secants here because we're hitting the circle twice. So I'm going to start with this one. So anytime I have a secant, I know it's the outside piece, 4, it's pretty easy, times the whole entire secant. All right, little mental math for me. What's the length of that entire red secant? 9. 5 plus 4, 9. We don't have to write 5 plus 4. We can just do 9. Okay? Now, the green one. Easy enough. The outside is 3. What algebraic expression are you writing for the length of the entire green secant?
3x.
Close. 3 plus x. We're going to add them together, just like you added to get the 9. You could have that x plus 3 too, same thing. Okay, there's the geometry part of it. That's the easy part of it. Now we're going to do the algebra. 4 times 9, well, that's easy. 3 times 3, 3 times x. Oh, this won't be so bad to solve. There's no squared. We're just going to get x alone. I'm going to subtract 9 over. Then we divide by 3. Now redo directions close. Final answer, TS. What's TS?
12.
That would be TR. What's
9.
just 9? We just need the x, which is 9. I know, so easy to make a little tiny calculation error. Look closely at your pictures. So secants, remember, touch the circle twice, because they're going to start scrambling these pictures up on you. Secants touch twice. Outside times the whole thing. All right, let's look at it. Secants, touching the circle twice. Doesn't matter what you start with. I'm going to do this one. So outside 5. Now, the whole entire red secant, you would have to add x and 5 together. Green secant, outside 6. Little mental math for me. What's the entire length of the green secant? 15. 9 plus 6. So there's the geometry, the easy part. Let's just distribute. 5 times x, 5 times 5. Might need your calculator for that. What's 6 times 15?
90.
90. You guys are great at solving equations. I'm going to give you a sec, finish that off. You get a nice whole number.
It's equal to 13.
You got it. Okay, is that all I need, or do I have to plug it in?
That's all you need.
All we need, find the value x, done, love it. So secant, outside times the whole. Let's see what we got in the next picture. Again, 2 secants. Again, how you know, touching the circle twice. Doesn't matter which one you start with, I'm going to do this one. Okay, outside's easy. Now, the whole entire thing. Some of you can mental math it. You're going to have to add these together. Well, the ones are going to cancel. What's x plus x?
2x.
2x. I don't know if I really need parentheses on 2x, but I already started drawing it, so I'm just going to leave it. So I'll distribute 2x in a minute. Okay, green one. Outside's easy. What's the length of the entire green secant? What's your expression for it? X plus. If you add these together, I would combine the 3 and 2 and make it x plus 5. So that's where it's going to get a little tricky, is you're going to have to do some combining of like terms. There's a fancy word for you. Okay, let's distribute the 2x through, 2x and x. Already I'm thinking factoring because of the squared. 3 times x, 3 times 5. Got it. Now, squared, factoring. Oh, well, okay, never any problem. First, we got to set it to 0, though. So I'm going to subtract 3x over. So that's going to be easy to combine. And let's subtract the 15 while we're at it. So we got a lot of stuff on the left. I'm going to put it in the correct order, meaning I'm going to make sure I put the 2x squared first. 2x minus 3x. And then don't forget your minus 15. Okay, factoring. Now, I can't just go, hey, what multiplies to negative 15 and adds to negative 1? I mean, there isn't anything, first off, okay? And you've got the 2. So now we have to do that long factoring process where we multiply the outside two numbers. 2 times negative 15 So we need to come up with something that multiplies to negative 30, adds to negative 1.
Negative 6 and 5.
Perfect. Key step, you're going to divide both of those numbers by what?
2.
2. Now the 6 over 2, you can do that in your head. We're going to have negative 3 there. Let's just put x minus 3. Bottom number, remember, goes in front of the variable, so 2x plus 5. Okay, so there's the factoring. What are your two potential answers for x? First one's easy. What lovely fraction do you get off this? And which one do you think I'm questioning?
Negative 5.
Yeah, because that's negative 2.5 if you like a decimal. If you put negative 2.5 in here minus 1, you're going to have a negative segment line. So I'm just going to keep the 3. Whew! Okay, so remember, this line was the geometry part of it. The rest is a lot of algebra stuff. And again, we're doing that on purpose so we can review some of your algebra skills, thinking about you guys taking Algebra 2 next year, of course, in standardized testing. All right, last one we have for you, the bottom left purple circle over there. So we're going to throw in a tangent now. Okay, so the blue, mine's blue, is the tangent. It only touches the circle once. When you have a tangent, we're going to square it. Then, of course, you have your secant, which is always still the same calculation on secant. And if you don't like external, remember you can do outside. I'm going to fill in the blank. Final 2. Now, like I said, tomorrow, next couple of days, you really got to look close at your pictures because they're going to be scrambled up. You might have chord, it might go to a tangent, you might have secants. You really have to look at your pictures close. So, right away, it's like, ooh, tangent. How do I know? Touches the circle once. So tangent, I square it. I'm going to do 12 squared. I know you know what 12 squared is. I'm just going to jot it down. Now, my other piece is hitting the circle twice. Secant. Anytime it's a secant, outside times the whole thing. My outside's 8. Whole thing, we'd have to add them together. X plus 8. So there's the geometry. That's super easy. 12 squared, 144, got it. 8 times x, 8 times 8. Let's subtract 64, finish solving it. You're going to get a nice whole number for x, I believe. All nice whole numbers today. What do you got for x?
X equals 10.
Perfect. Now, final answer. AB. What's AB?
10.
10, which is also x on the picture. So I'm going to roll with that. So tangent touches the circle once. If you have a tangent, you square it. If something calculations, we keep straighten our heads here with this chapter. All right, final one. This is a good one. So again, I should have a color copy machine. I'm going to start with the blue. I see it as a tangent. Touches the circle once. Tangents we square. Okay? Now, red, secant, touches the circle twice. So I know secant is the outside, x, times the whole thing. Well, I would have to add x and 8 together to get the overall length. There's the geometry. Easy. All right, 16 squared, you probably need your calculator for that. What's 16 squared?
56.
Got it. And then let's distribute x. Now, squared, something we're going to have to factor. I'm going to subtract 256 over so we're set equal to 0. And then it's going to get good. Question for you. Do you think there's anything that multiplies to negative 256 and adds to 8?
Yes, but it's probably going to take a long time to find.
Potentially. Notice that little rectangle on the right side of your notes there, that formula. What's that formula? Do you remember the name of it? Stars with a Q. Anybody? Anybody? Quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I know you wanted me to sing today. Now, why is that on there? Yes, So we can review how to use quadratic formula because this does not factor. There are not two numbers that multiply to negative 256 and add 8. So let's review quadratic formula because why wouldn't we on a Monday? There's A, B, and C. I'm going to scroll it up. Because we're definitely going to need a calculator for this one. Okay, plugging the numbers into the formula. X equals the opposite of B. So I'm going to put negative 8 plus or minus the square root. B squared, 8 squared. I'm not writing 8 squared, I just know it's 64. 4 times 8 times C all over 2A, 2 times 1. Now, I am not going to try to even attempt with the 256 to do any of that in my head. I'm going to pull up my calculator here in a sec, and I'm going to type that in. You might already be typing it. I don't know. Let's pull up the calculator here. So I'm going to type in exactly what that says under the root. 64 minus 4 times, all right, I lied to you. I'm not going to do the times 1. I don't mean times 1. That doesn't matter. I'm not going to do the times 1. Times negative 250. Oh, 1,088. That's nice. Okay, that's really swell. Now, 1,088 is pretty big. I don't know about you. I sure don't want to try to simplify the square root of 1,088. Nowhere in the directions does it say I can't use a decimal. Winning. So, next up, I'm going to punch in the old calculator the square root of 1,088. Square root. Okay, all right. I was right. It's a decimal. Let's make our lives easy. Let's just round that up to 33. Seems reasonable. Okay, a little mental math here. Remember, 2 answers every time you solve a square. What's negative 8 plus 33? Or if it helps, 33 minus 8.
25.
25. What's 25 divided by 2? Can you do that in your head?
12.5.
Perfect. So there's one potential answer. What is negative 8 minus 33? Negative 8 minus 33.
41.
Negative 41. What's negative 41 divided by 2? Yeah. And which answer do you think I have the problem with?
1.5.
Yeah. So we're going to keep the 12.5 for my x. Now, I haven't forgotten the directions. It says find RS. Well, RS is just x. I'm just going to throw RS in front of it, and there we have it. Okay. How many problems on your homework do you think you have to use quadratic formula on?
1 or 2.
Not even that, Carter. 0. Okay, 0. So I'm like, oh my God, why is she torturing us and making us do this? To remind you of how to do it in case like you see something on the standardized testing, etc. next month. Like I said, you're going to see me throwing some algebra stuff kind of in here, thinking about your standardized testing. Okay, so let me grab your worksheet for you. I'm going to give you that. Like I said, if you need to finish